All right, so we're on the back. Let's go ahead and knock this out. So we've got a right triangle FGH is shown where the measure of angle G is not equal to the measure of angle H. Now the only thing that that's going to tell you, right? So you got G and H over here. Those have to be the acute angles, right? Which means they've got to add to 90. If they had happened to be the same, then you would have had a 45, 45, 90, and then you've got a special right triangle. So by telling you that these are not the same, that's all it's doing. It's just you know that the angles are not 45. Okay. Then it tells you the cosine of G, so this angle up here, is equal to 12 over 13, and they want to find the sine. Okay, so we're going to think for just a second, right? If we write out SOHCAHTOA, right, here's what you absolutely know about trig functions, right? They have to fit this. If it gave you a cosine, right, if I were to write that out, remember it's cosine of the angle, right, and that's equal to the side, right? So side over side. That's what that is. All right, so if I look back in what they gave us, cosine of G, that's my angle. These are really just side lengths. So a cosine is adjacent. This is the side that would touch G, so that's a 12, and over a hypotenuse. Okay, well my hypotenuse would be over here across from the right angle. That's a 13. All right, so if they want you to find the sine, that's fine, but you're going to need this piece, right? We're going to need that side opposite. All right, well if you have two sides, that's just going to be a Pythagorean theorem, right? So m squared plus 12 squared is going to be equal to 13 squared. So m squared plus a 144 equals 169. And if we subtract, m squared should be equal to 25. Take a square root, and so m is equal to 5. All right, so the sine of G should be opposite over hypotenuse. It should be a 5 over 13. And there you go. Right? They could have done the same thing with a tangent or anything else, right? But again, what we've given you is our side lengths. And so put those on your triangle, use some Pythagorean to go ahead and find whatever you're missing, and then you can answer your question that way. All right, 11 and 12. These are both going to be word problems. On your test, you're going to have to show us, you're going to have to draw a picture. It's going to have to be labeled. So as we're reading, you've got a fire hydrant that's 72 feet from a building, and the building is 125 feet tall. Find the angle of elevation. Okay, so what I have encouraged is as soon as you see those words, let's go ahead and draw those parallel lines. All right, I'm going to go ahead and throw the transversal in. You're in a unit on trig. It's got to be a right triangle, so let's go ahead and drop that. Okay, fire hydrant. Again, forgive my drawing, something like that. Here's your fire hydrant. Okay, it sits 72 feet from a building. Fire hydrants are on the ground. All right, so if it's 72 feet from the building, that's this side right here. All right, and then it tells you that the building is 125 feet tall. All right, well, here's your building. It'll be over here. This one is 125 feet. Find the angle of elevation. Remember that the angle of elevation is the ground up, right? Elevation rises. This is the piece that you want. Oops, sorry, degrees, not squared. Now the angle of elevation is the same thing as the angle of depression, right? Angle of depression is right out here. But within parallel lines, remember that the angle up here and the angle down here, those are going to be the same because they're alternate interior. All right, so as we look at our picture, this is the angle that we care about. Across from it, this side would be opposite. This one would be adjacent. So we're looking at a tangent. So the tangent of the angle is equal to opposite over adjacent. Now, if we want the angle, that's an inverse function. So on our calculators, that's the second key. So tangent looks like tangent -1, but we read it as inverse tangent, and then we enter the fraction just like we wrote it. We don't flip or anything. All right, so inverse tangent of 125 divided by 72, and that looks like rounded, it said to the nearest tenth. So that 5 would bump that 0 up, so it should be a 60.1 degrees. Sorry, 60.1. There we go. right? You're finding an angle, so you want to make sure you've got that degree symbol after it. And we should be good to go. So then we look at the second one. The surfer's going to be writing a wave angle of depression. So again, as soon as I see it, here we go. Right, writing a wave. I guess we'll use pink. It doesn't really matter. Here we go. All right, so if a surfer is riding a wave, right, surfer, pretend, right, there's a surfboard. The wave should be, like, he's riding the top of it, right? So if it's a 7-foot wave, that's going to go here, right? This is measuring my wave, right? And then the wave is going to come down, right, crashing to the shore. Okay, so this is the ground, right, or the water, however you want to think about that, right? But that's going to be that horizontal, and then this is going to be like where he would meet the shore. Okay, that's going to kind of be that shoreline. Angle of depression is 10 degrees. Okay, well, depression is what goes down. But remember, with parallel lines, right, that's what we drew first, right, that the angle of depression is the same as the angle of elevation. They're alternate interior. So even though they didn't give it to me, I know this angle. All right, then the question becomes, okay, how far is the horizontal distance from the shoreline to the surfer? So this is the piece that we want. All right, and I'm also noticing that's going to be adjacent. All right, so if this is my angle of reference, right over here, this one touches, this one doesn't. So again, we're looking at a tangent function, but this time we're going for side. So tangent of 10 is equal to opposite over adjacent. All right, so x is going to be equal to, again, this one's going to be a division, 7 divided by tangent of 10. Oh, I apologize, you didn't see that. There we go. 7 divided by tangent of 10. And so my length should be a 39 point, what are we rounding to? 10th, 7. Now, in word problems, you always want to go back and make sure that we've got any units in there that we need. So I'm noticing it says 7 feet, so it should be 39.7 feet. That's his distance to the shoreline. All right, number 13, here we go. Perimeter. Now, perimeter, remember, that's going to be the distance around. Right, so the outside of the shape would be the piece that I walk. So I'm noticing I have this side, that's a 4.5, that one's done. I have this side, that's a 3.2, that one's done. But I would also need this piece right here, D to C, and I'm also going to need D to A. All right, so those are going to be my two missing pieces that have to comprise the perimeter. Now, as we're looking at this, I'm also noticing, for better or for worse, right, I've got two triangles. The top one, that's where all the pieces are that I need, but I don't have any information about that. So I can't start with that triangle. I'm going to have to start with the bottom one. I've got two sides, which means I could find the third, right? I could find this one. And to both triangles, this one's going to be the hypotenuse, right? It's across. If I've got two sides, I can use Pythagorean. So we're going to go ahead and start there. So 4.5 squared plus 3.2 squared is going to be equal to my hypotenuse squared. All right, so 4.5 squared is going to give us 20.25, and 3.2 squared is going to give us 10.24. And then if we add those, should get a 30.49. And so last step, go ahead and take a root. And so we're going to get a 5 point, and it says round to the 10th, so 5.5. And there's our hypotenuse. Now, unfortunately, I don't need that. Like, this piece isn't part of my perimeter, so I'm not going to need it for my final answer, but I do need it to keep going and find these missing pieces. So at this point, then I'm noticing here's my 27. I have a hypotenuse. From the 27, this side would be opposite, so I'm going to go ahead and start with that one, but again, it's your choice. It doesn't really matter where you start. So opposite hypotenuse, that's going to be a sine function. So sine of 27 is going to be opposite over hypotenuse. So to get the opposite side by itself, we're going to go ahead and multiply. Right, and my opposite side, that's really d to c. We'll put that in there. So 5.5, sorry, so you can see 5.5 multiplied by the sine of 27. That should get us and we're supposed to round the tenths, so 2.5. That one's going to be d to c. Now this piece I am going to need, right, 2.5. I am going to need that to be part of my perimeter. All right, then I'm looking at the other one. Now again, this side actually touches the 27. That's going to be adjacent. So this is going to be a cosine. So cosine of 27 is equal to the adjacent times the hypotenuse. So again, we're going to multiply. So 5.5 cosine of 27 is equal to the adjacent side. And that one's going to be a 4.9. And that's adjacent, which is really d to a. Now again, if you've got the time and the inclination, like you could check this real quick. Okay, so 4.9 squared, because that's a side, right, a leg, excuse me, plus the 2.5 squared, right? If I root that, it should come out to, hopefully, 5.5, which it does, right? So again, just kind of a quick check before you get going, a quick check to make sure you're doing it right. So perimeter, right, we already kind of traced the sides that we want, so now it's just a matter of adding. So 4.5 plus the 3.2, those were given. And then we just found 2.5, and d to a was 4.9. All right, so we put all those in the calculator. 4.5 plus 3.2, 2.5, 4.9, and we should get a 15.1. Now again, we didn't give you units this time, right? But just as a reminder, perimeter is always whatever the units are. We don't do anything to it, just units. If it had been inches, it's just inches. If it happens to be an area, remember it would be inches squared. If it happens to be volume, which we're not quite there yet, but if it was volume, then it would be units cubed. All right, just as a reminder. All right, then we've got this last problem down here. Hot air balloon is launched and it drifts over a boat. Right, so we've got a hot air balloon up here. Your boat's down here. Again, we can assume a right angle here. The altitude, so remember that's just a height, right? So the altitude is increasing at a constant rate. That just means it's not speeding up and slowing down, right? The hot air balloon is just rising. It's not changing. The balloon is directly above a boat, 400 feet away, right? So here's your 400 feet. So again, your hot air balloon started over here and now it's drifting. So the boat was 400 feet away. You've got an angle of elevation of 72. So again, that's down here in our corner. And then it's got this piece that's, it's doing this after 5 minutes, right? 5 minutes after it's launched. So we'll come back to that here in a second. Find the altitude, again, fancy word for height, right? Find the altitude of the balloon when it's directly over the boat. That just means at right angle. So this is going to be the side that we're searching for. So again, here's my angle of reference. Here's my right angle. This side's hypotenuse. This one touches. This one doesn't. So it's going to be a tangent function. So we've got tangent of 72 is equal to the opposite over the adjacent. All right, so we're going to multiply. So 400 multiplied by the tangent of 72, that's going to be equal to our altitude, or our opposite side. So again, if we punch that, 400 times the tangent of 72, and that's coming out to 1231, does it say how to round? Round to the, it doesn't say. Like it says round to then we must have cut that off. We're going to say tenths. Our answer key said tenths. We're going to add tenths there. Sorry about that, guys. All right, so it looks like 1231, and then I've got a 7, so that's going to bump that up to a 1. All right, and then it was feet. There we go. Okay, so the hot air balloon is roughly 1,231.1 feet over that boat. Now, it wants to know what is the change in altitude, in feet, of the hot air balloon for each minute. Okay, well, anytime you see each or something like that, that usually indicates a division. So if we go back up here, right, we're noticing that this change, this elevation happened over 5 minutes, right? My balloon started at some other distance and it's been rising, rising, rising. This happened after 5 minutes. So if I want to know each minute, then I'm going to take my total and I simply divide by the amount of time it took me to get there. All right, so if I take this 1231 and we just divide by 5, right? Now again, this one said round to the nearest foot, right? So this looks like 246.2. Now if I want to go to the nearest foot, right, my 2, it's just not going to change anything, right? I only round up if this happens to be greater than 5. So my nearest foot would be 246 feet. Right? So roughly 246 feet every minute, right? So if I took this and I multiplied by 5, I should get back to how high it was after 5 minutes. That's the idea.